So instead of rewriting everything, we'll just walk through this. Okay, I want to put this, find the axis of symmetry for each of these. Now, being that we have a is not 1, I'm not going to bother with completing the square. So I'm just going to use the opposite b over 2a for the axis of symmetry. So a is 2, b is a positive 4, and if c is negative 6, we don't need that. So x equals the opposite of b, which is 4, over 2 times a, which is 2. So I get negative 4 over 2, negative 1. Do the same thing in 2. Now the issue in 2 is, notice it doesn't look right. It doesn't look like this. So we rearrange it. Negative 3x squared, negative 9x, and negative 3. Make it look nice. So now a is negative 3, b is negative 9, c is negative 3. So the opposite of negative 9 over 2 times 3. So that's a 9 over negative 6 reduced to negative 3 halves. So, vertex of the graph of the function. Well, this one is a little strange. You could look at it like we did before, up here, where 5 is a, b, since there's no x, we would have 0 for b. 0 plus 0x, so b would be 0. So the opposite of b over 2a, which is 0, over 5 times 2, or 10. 0 divided by 10 is 0. And then plug it in. Or you could recognize this as, in order for us to get only x squared, we have to, what could we subtract? Or in other words, vertex form, x minus 0 first, then squared. So now vertex form, what makes x minus 0, 0? Huh? Yeah, 0 minus 4. And so when we do that here, so it's in vertex form. What makes x plus 2 equal to 0? Pause it if you need to write anything down. X plus 2 equals 0. That gets you this, which is your axis of symmetry. And what's outside is your y-coordinate of your vertex. So 5. Do the same thing as we did before. With a not being 1, I'm not going to bother with completing the square. Just going to go the opposite b over 2a. So a is 2, b is 24. So the opposite of 24 over 2 times a, which is 2. So negative 24 over 4, negative 6. Plug negative 6 in, what we did here, and I got negative 88. Check my calculations. So same thing with this, opposite b over 2a. So a is negative 2, b is 8, c is negative 20. So the opposite of 8 over 2 times a, which is negative 2. So we get negative 8 over negative 4, 2. Plug it in for each x. Order of operations, negative 12. Again, order of operations. So square the 2 first, then times the negative 2. Square the negative 6, so I get 36 times 2, 72. That's why it gets so big. Actually, it got so big because of the negative 24 times 6. So this one is really just, the way this is saying here, what value completes the square? Think about what's in the blank. I was trying to write that down here. So if I'm thinking about what do I put in for the blank? Okay, so what's half of 16? Square that 8. That's what it's saying. So if we needed to write it out, that's what it would be. So vertex form. Now, in 8 and 9 and 10, we could do what we did up here. And then now that we got the vertex, go ahead and write it as y equals a times x minus h plus k, and we get the same thing. But let's practice completing the square since a is 1. So set up the form, group the x's together, so the x squared minus 2x plus your blank. Close the parentheses, plus 8 from here, minus the blank. So parentheses, x and I put x, with some space, close parentheses, squared. So half of negative 2 goes right there. Square negative 1 goes into blank here. Now since we're adding 1, we're going to subtract 1. So where does this number come from? The 7? 8 minus 1. One more time with 9. Just rewrite it over here. So get the x's together, gather the x's, group the x's together. So x squared plus 8x plus a blank. That's what we're going to complete our squaring. Close parentheses. Bring over, here's the minus 6 minus that same blank. So parentheses squared. Bring, of course, the x state is there. So half of 8 squared. So take that 4 and square it. And again, we're adding 16 here, so we got to subtract 16. Because plus 16 minus 16, 0. No change in the values, just change the way it looks. So negative 22. And again, we're just completing the square, completing the square, completing the square for this. It's going to seem repetitive and redundant. With a is 1, I'm going to do the same thing. Set up the form, x's together with the blank. Below, got an x space squared outside the parentheses. Half of 10. That's the b. Half of the 10. Positive 5. Square that. 25. Add 25. Have to subtract 25. So 16 minus 25 is 9. So the vertex is negative 5. What makes that 0? Negative 9. Okay. You could do the same thing for number 11 if you wanted to the graph. I decided not to do that. Why? Because I didn't want to. It's a flip. With a equal 1, it's a flip a coin. When in graphing, I'm not going to tell you which way to do it. At least now. So opposite b over 2a, we get x is negative 2, plugged it in, negative 2, negative 3. Pretty quickly. So then, I'm going to go to back to the notes, graph last page. So find the vertex and axis of symmetry. Here it is. So here's the vertex. I happen to get some values close to, I use negative 1, 0, 1. Plugged it into the equation. That's how I get these y values. Here, here, here. So I was 1 right, go 1 left. 2 from the axis of symmetry, at x equal negative 2, go 2 left. 3 right, 3 left. Now, if you would have picked negative 3, negative 4, negative 5, you'd get those same y values. But over there, no, you wanted to plug 3 more values in here, go ahead. You don't have to, you could. Back to number 12. We could do the same thing, opposite b over 2a if you wanted to. But with just x squared, it's really this vertex form and hiding. X minus what? X minus nothing before squared. So it's x minus 0. 0 is my x at the 0 for the coordinate for the vertex. If you wanted to remember that as a shortcut, go right ahead. But that's only with x squared with no x. Or you could take the opposite b, which over 2a, b is with no x, 0. 0 over negative 2, 0. Ta-da! Then we plug 0 in here, we get negative 1. So, going to go back to the same thing. Values close to 0, so 1, 2, 3. Why? Yeah, I wanted to. Remember the order of operations. So 1 squared times a negative 1, then minus 1. 2 squared first. So 4 times a negative 1. That's what that means. So again, those values, if you were to use negative 1, negative 2, negative 3, you'd get the same y values. So again, when we're plugging into here, oops, sorry about that, we're taking 1 squared times a negative 1, then minus 1. 2 squared times the negative 1. So that's negative 4 minus 1. Watch that order of operations. It would be no different than this was, where is it? Up here, we would square the negative 6, then times 2. Square the 2, then times negative 2. It's just that we don't write in -1. Just write the little negative sign in front of it. Okay? I think we could go. So, same old, same old. Same thing here. Here you can see what I looked at for the axis of symmetry. Does this seem repetitive and redundant all over again? Well, it should be, because it's the same stuff. So 2 times 2 for A, 0 for B, plug it in, we get 0 for x-axis of symmetry, x equals 0, plug in 0, get -7. Again, plug it in, again, 1 squared times 2, -7. 2 squared, 4, times 2, 8, -7. That's where we get those numbers. Again, if you use -1, 2, or 3, and way up here at 11, off the grid. Show this table. 14, same thing. This time I'm not going to bother with that opposite b over 2a because it's in a nice vertex form. Where x minus 7, what makes x minus 7 equal to 0? And then now it's outside. Again, just plug them in. Again, why did I plug in 6, 5, and 4? I wanted to. You could have done 8, 9, and 10. Get those same y values. And then just plot it. If your graph is not looking like this, something's wrong. So these should always look like a U. Always look like that parabola for these. Either pointing up or down. Positive A, pointing up. Positive A, pointing up. Negative A, pointing down. That's again another Kubitschek to go through. Okay, so there's 13, 14, 15. Wait, look at all those graphs. How are we going to tell? We're going to tell with all this stuff. Well, so a couple different things. Well, first of all, what's the vertex? Which one's in the right place? Well, right now I'm looking at these. I know it's a little hard to see, but my vertex is 2, -4. What makes x equal to 2? X minus 2 equal to 0. And outside. So let's see here. There's we got 2 things, A and B. These other ones are in the wrong place. But what A being -2, which way is it opening? Down. So that's really what that one's checking. Vertex somewhat, but also down. That's the difference between these 2 choices. So same thing when we get to 16. So should get a little closer. So again, these look like these choices are in different places. Not going to have many multiple choices on the quiz, but the big idea is still the big idea. So where's your vertex? Because they're different places, different vertices. So the opposite of B is -4 over 2a, a is 1. So the opposite of -4 over 2 times 1. So 4 over 2, x equal 2. Plug it in. So 2 squared minus 4 times 2, so 4 minus 8. -4 plus 1. Plus 5 is 1. That's what I was thinking of. So 2, 1, 2, 1, 2, 1. Which of these graphs have the vertex at 2, 1? So 2 to the right, 1 up. That's it. The only one. We're done. B. That's the whole idea behind these. Okay? I know I went through some of them fast, but the writing's in front of you. You have it all written down.